Thank you, Simon. The presentation so far have explored frameworks and concepts and approaches at a general and really global scale. But the big challenge is to make these useful at a scale of a protected area or even within the country. I talked about in my presentation, I referred to a workshop held in Germany in June, where we explored from a number of countries and regions the applicability of the EBB framework to national or subnational programs. But now we want to focus on individual protected areas and management of these protected areas. So David Keith from Office of Environment Heritage will explore adaptive monitoring as a part of adaptive management.
Thanks, Aaron. I'll get straight into it. What is adaptive monitoring? Well, here's a definition. It's responsive, problem-focused collection of time series evidence about environmental change. And it's purpose-driven. So we're collecting that information to improve the management of protected areas, ecosystems and natural resources. Here is my one conceptual diagram. We start with some context. The first is that there has to be a need to know. And that's often driven by social imperatives or sometimes legislative mandates or management plans. And there's always an existing base of knowledge. It's rare that we know absolutely nothing about a system. And the first, I guess, step towards adaptive monitoring is trying to organise that understanding into a system model, a set of beliefs, if you like, about how a system works. Now that can be the basis for developing some tractable questions about change and perhaps focus attention on particular target resources or areas or systems that require attention and monitoring over time. Once we have that question or questions, we can start to develop a rigorous sampling design and statistical design, and that involves things like choosing appropriate sample sites and monitoring variables that are focused on the question as stated. And then there's the actual doing bit, the monitoring, which of course has to be sustained over time to collect a meaningful time series. And we have to manage the data, curate the data, and interpret it as we go along. And that regular interpretation is important, even though we might not be comfortable that everything's complete at some point. It's worth reviewing what we have and what the trends are starting to look like, because that's the process by which we learn, and we may have learned something quite important that leads us to adjust our process model or system model, our set of beliefs about how the system actually works. And we also learn something about how we might actually adapt our monitoring to focus more effectively on the problem. And there's a couple of other issues that might lead us to adapt our monitoring. One is evolving technology. We may be able to do things tomorrow that we never dreamed of today. And there's plenty of monitoring programs that have gone through that experience. And changing resource availability is always something that's part of the environment in making decisions about ongoing monitoring as well. I want to give you, or cherry pick 3 examples out of a program called, in Australia called the Long-Term Ecological Research Network. And all of these 3 examples are based in protected areas. Just to give you the sort of idea about the kinds of work that's involved in this adaptive monitoring. The first is alpine monitoring, which has been carried out at present by Dick Williams and colleagues. And actually was initiated by Maisie Carr in 1947 and later further enhanced, if you like, by Dick and colleagues in 1979. The original question was, what's the effect of livestock grazing on biodiversity in these alpine landscapes? And it's been a long-running and relevant question in Australia for quite some time, to the extent that initially much of our alpine area was grazed by livestock, and then in New South Wales in the late 1950s and early 1960s, livestock were removed largely because of the effects that activity was having on water supply infrastructure that was newly constructed in the snowy mountains of New South Wales at the time. So we have this contrast between parts of Victoria, which are still actively grazed, and New South Wales, which has been retired from grazing now for some decades. But in Victoria, there are these long-term sites where grazing has been excluded, and you can see there some long-term data from around about the late 1940s, where populations of the snow daisy, which you can see in white there on the second photograph, are starkly contrasting between the grazed and ungrazed treatments in that experiment over time. New questions have arisen during the course of this program, and one of those involved climate change. And so in the early 2000s, infrastructure was set up in the same site to artificially warm some plots of these alpine herb fields and grasslands. And that's now been running for 8 years, in fact a little longer than that now. And the results from that seem to show that certainly shrubs are increasing in their growth rates, and there's early flowering happening, but the effect sizes at this stage are fairly small, and there's actually no detectable effects on species composition of the herb fields. You can see in the data there that the dotted lines and the unbroken lines represent the two different treatments, warmed and unwarmed. So that's an example of how an existing project has been adapted, if you like, to take on a new question. Here's another one. This is an area where I work in far southwestern New South Wales and the southeastern part of Australian deserts. And it's a fire-prone area. There are mosaics of patches that have different ages of fires, and quite a lot of this landscape that you can see on that little coloured map there is white, which means that there's been no recorded fires since at least 1917. So the question was, does diversity, are we losing species from these long unburnt patches that start, seemingly to the eye, seem to be degrading and becoming quite species poor? So we did a series of experiments and monitored them over time. And when you do burn those older sites, they seem to have identical composition to much younger sites. So the answer to that question fairly simply turned out to be no, we're not losing diversity, at least after 100 years. You can see the yellow and the green dots all mixed up there, which indicates that there's no difference between those two fire histories. A new question that emerged during the course of that work was, well, how does variations in climate, and particularly rainfall, affect the populations of these plants, and how does that interact with the herbivores, some of which are introduced in this landscape? So again, we've adapted the original design and set up some exclosure plots to look at these, and some of those are now about 15 years old. And I don't have time to tell you much about the very interesting and rather complex results emerging from that. And just finally, the third example is an example just down the road. If you were out yesterday with us down at Royal National Park on one of the field trips, we've been monitoring an interesting long-lived plant down there for 25 years, have long-term trends in that population, and discovered from that work that there's a cryptic decline in the population that varies between sites. At some sites it's as high as 20%, and other sites it's as high as 40% or more. And this is something that was completely undetectable if this detailed monitoring had not been undertaken, because the plant is still relatively abundant, and you walk and drive around and you do see it everywhere still, but nonetheless that's a substantial decline, and it may have implications for ecosystem function. we've done some work using the data collected from that demographic monitoring over the time to construct some models to explore the options for managing those populations in a more sustainable way. One of the key factors that has emerged is a root rot disease, which interacts with fire. And you can see these two diagrams on the right indicate that the management option that you might choose with fire depends very much on whether or not the site is infected with the disease. In fact, the order of what fire management strategy produces the best outcome for the population in terms of viability is completely reversed depending on whether or not there's disease. So, what's the keys to success for this kind of adaptive monitoring? Well, it starts with a well-formulated, tractable set of questions and ongoing development of new questions. And that sets it apart from other more generic monitoring approaches, I think, which aim to develop broad-scale general variables that are widely applicable across landscapes. It's much more carefully focused on what's the problem in this system. Robust sampling design is absolutely crucial. High quality data collection and curation is also essential. The strategic adaptation of the monitoring and calibration is also very important, and there's a few other issues there that I won't go through right now, but they're all documented in a book that's available on the Altern website. The benefits, primarily this is an approach that promotes experimentation and diagnosis of the causes of change, and it is an approach that lends itself to scaling up, although that's not yet been done in Australian environmental reporting. The existing network is pretty sparse. Its coverage is not too bad. We have coverage across a range of systems, but there are some key gaps that we're looking to fill in the box there, and that book details what we have so far. Thanks very much.